Welcome back. This is our last but one of today and the end of the conference. So thank you for joining us. So this is session 7R. This is Elijah Swift from IBM who's doing a transforming security automation talk for us. So thank you for joining us. Any chat can be put into the chat window, or I'll unmute you in a bit and you can ask questions on your own. So thank you, Elijah. I'll leave it with you.
All right. Well, good afternoon and good morning and anywhere in between to all you lovely folks. My name is Elijah Swift, and as stated, I'm here to talk a little bit about security automation and simplification of security interfaces on the platform. For those who don't know me, I worked in support for specifically RACF, but also other mainframe security software for a number of years. And now I'm still a software developer with IBM, and I work closely with those components, but I'm not in support anymore. Oh, clicked the wrong. So just a high-level agenda of what we're looking at talking at today in this presentation. I'm going to speak a little bit to what I mean by simplification and kind of what I would refer to as a simplification mindset for trying to take a look at these kinds of interfaces like RACF or other sorts of security products that are out there. I'm going to speak a little bit about PyRACF. It's a open source solution to RACF simplification that I've been heavily involved with. It's a lens through which we're going to look at simplification overall, and an interesting product that I want to show off a little bit. Then I'll move forward to speaking about making sort of a universal solution out of this kind of content and information. And then we can look a little bit to the future about what's coming next for PyRACF, other kinds of efforts, or how you can get involved in similar efforts or do similar kinds of things in your own spaces if that interests you. So to move along, I want to speak a little bit about the current state of RACF administration. I am going to open with, I'm sure a lot of folks here are RACF people. I would consider myself to be a RACF person. These interfaces aren't necessarily complex, but they can be scary to people who aren't mainframe folks. And they have their own share of drawbacks. So looking at kind of a holistic overview of not looking at OEM products, not looking at paid offerings, just base, how do I interface with RACF in a mainframe environment? I think the three things that really crop up most commonly is you would see TSO commands like we have here, classic list user command from RACF perspective, the RACF panels like you would see here, where the output is also human readable and you have little fields to fill in, but you might have trouble integrating that into other programs. And then lastly, kind of coding your own either assembler or in some cases C kind of interface into the RACF callable services, which are another way to interface directly with RACF. And the big drawback there is just it can be a lot of work for a very simplistic and single use case kind of solution. So that kind of leads into the question of why try to simplify RACF? Again, mainframe security has a lot of great qualities. I'm not trying to make the argument that RACF isn't modern. It's in a lot of mainframe environments. Mainframe environments do magnificent things. And once you know RACF and once you understand its quirks and idiosyncrasies like anything else, it is simple enough and easy to work with in many cases. So I'm not trying to dissuade you from using it at any capacity. But the two big pain points and areas that we looked at in terms of trying to make things simpler, we were hearing a common thread among customers is that there was a lot of new hire overhead. If you're onboarding someone from a security position, but not on a mainframe platform, or a new hire out of college who may never have really worked with mainframes before, because that can be kind of difficult, it can take upwards to a year to try and get them to be productive as system programmers in these kinds of environments, because in addition to understanding RACF, they might have to understand TSO and ISPF and the various technologies that they'll need just to interface with the software that they have to learn. Additionally, something that we've heard a lot is that a lot of customers and people out there really want to integrate with and take advantage of tools and standards that are already out there working with lots of complex languages and other sorts of environments and opportunities that are out there. But RACF in its current state doesn't always play well with those kinds of opportunities. It needs some form of an interface that could be used to do that. Um, so with that as kind of the use case and what we were trying to look at in terms of a simplification mindset, we took this as, okay, well, what do we want to create? We want something that has consistent and well-structured, that takes in consistent and well-structured input and gives out consistent and well-structured output. We want that to be something that's straightforward and consistent, both easy to review for a human, like TSO commands can be, but also easy to review for a program so that it could easily be digested and integrate cleanly with tools, which is kind of the next bullet point here. You want something that's going to be easy to integrate with the standards and tools that are already out there, that even if you don't want to leverage, other folks might want to, especially as part of developing an open solution. We thought that that would be a crucial aspect to this, is being able to integrate with as many and be consumed by as many different tools as possible. Um, One of the biggest things as well is you want something that's straightforward to use. You want something that's easily understandable. It says if I want to do this operation, the way of doing it should be straightforward. Um, and the last bullet point that I really wanted to stress is that we don't want what feels like a case-specific solution. Our goal is to build a building block, as the image on the right kind of suggests. We want something that could fit in and other software could build on for any specific solution that they wanted. But the core of it, the base root functionality of kind of a simplification and a simplified interface should be something that anyone can build on. And so that's what we tried to accomplish. So looking at that, why use Python? Well, it's widely known and used. I've got some statistics here and a word cloud showing Python being one of, if not the most popular programming language today. And it has that position because it's versatile and arguably easy to use. Um, Again, looking at our pain points and where we were trying to see, where we were trying to simplify things, we wanted to minimize learning for new system programmers. So we felt that people coming in from other spaces, other industries where they were still working in security, they might have Python experience more likely than they might have mainframe experience, depending on the circumstance. We also felt that due to the popularity of Python, it would be something that new hires out of college would be familiar with and would have an easy time getting involved with. The last bullet point here is that we wanted to leverage existing Python tools and toolkits for automation and education and other kinds of efforts. So we have an example here is Ansible is a great Python toolkit for automation. Jupyter Notebook's an excellent way to kind of document and create run books that are very interesting and educational and informative. And one of the demos, or the real demo that I have as a part of this presentation, is built with a Jupyter Notebook. So if you're not as familiar with that, we'll get into that a little bit more later. So I've kind of talked around PyRACF for a while without really speaking to specifically what it is. It's a interface to RACF administration in Python. It handles users and groups, resources and data, resource profiles and dataset profiles, your generic RACF options under the seturops command, as well as accesses to those resource and dataset profiles and connections between users and groups. So it's a way to allow Python to interface with all of those aspects of RACF administration. We're under the Ambitus branch on the Open Mainframe project. It's currently an open source library. I believe we're in beta now. And we're available. There's some links in the presentation to go directly to the repository as well as our documentation if you're interested to see or learn more. So the goal here, and something that we've tested and tried, is that it integrates seamlessly with automation and other kinds of existing tools in a Python space. Again, we're going to have a demo with a Jupyter Notebook that showcases that a little bit. It uses JSON-like dictionary structures as part of its well-structured input and output. Um, and again, specifics in a short while. And then we also have abstractions that allow for what we would consider a simple interaction with RACF. So if you are more of a power user, you could do the same kind of thing that you can with the RACF add user command, where you can specify all the traits, all the uh, fields you want to be populated with this user. But if you're new, or you just want to perform a specific operation for any other reason, there are abstractions that can help along the way. If you were told to go in and change a user's password, assuming you have the authority to do so, there is a PyRACF method of the user administration object that'll let you do just that. You just pass it the user ID and the desired password, and it's done. If you want to change the OMVS user UID, or the GID for a group or something like that, or just get that information to figure out what that is for a particular user or group. There are specific abstractions that make it easy to just go in and get that one piece of information that you want without having to build a larger interface or function call to make that happen. Um, so to speak a little bit just to the architecture of it, this is a small architecture diagram that just covers the nature of the way that PyRACF is structured. So we basically have these different administration objects that all inherit from a generic security administration class. So we've got our access administration, that's access to profiles, have dataset administration, et cetera, et cetera. So all of these administration objects inherit from the security admin class. That class works directly with the IRR SMO callable service that reaches down to that administration in C. There's a bit of interconnective tissue between Python and C layer there. And then that C code and then SMO as a callable service goes out and reaches out to RACF and passes information back up the chain to the end user at the Python layer. So here's just a simple pre-recorded demo. I might not show all of it. I might skip around depending on timing or questions. But it's just an example of going through what PyRACF can do in a Jupyter Notebook setting. So this is what Jupyter Notebooks are like for those who are unfamiliar. But it's functionally a method of having a Python script that's kind of interspersed with documentation or comments. And then on the side here, we have a mainframe view on an ISPF panels, and we have our RACF panels that we can go in and confirm that these updates are being made to users in real time. So right now we're checking to see if Anna Sky or Luke Sky, yes, there's some very heavy Star Wars theming on this demo, are existing in this environment, and they don't exist yet, just to verify that, and we're going to create them. But another nice feature of the Jupyter Notebooks is we can kind of run through this script line by line, make changes to any particular line that we want to change, and that can be nice from a kind of documenting code or procedure perspective, where you might also want to change things later. But to start, we really just have to import everything we want from PyRACF. We have debugging variable that we wouldn't expect general end users to use, but we have it here for the demo in case something goes wrong. And then we set up our user administration object. And that's all it takes to initialize it, is just to create it. Then we have this large library of traits that we want this user profile to have. So we want them to have the specific name, a password, an owner, but then we also have information from the OMVS segment, like their UID or their home directory or their TSO segment. So they have a specific logon proc and region size. And we create this Pythonic dictionary with that information. And then we just pass that information to a user admin.add call. And we see from our response that the user has been successfully added, but we also want to go over to the mainframe and go check it out for ourselves, because maybe we're a little bit skeptical. So if we go here and we check out our TSO and our OMVS segments for the user ID that we're trying to look at, we see that Luke Sky is here. They have the traits we defined. They have the name Luke Skywalker, and then we also have the TSO and OMVS segments and information that we populated as well. So that's just a way that we can validate that all of this took place and that this Jupyter notebook that's out there running really makes live changes to the system. We can also do an extract call on that user administration to get all of that information ourselves. And we're going to scroll up and take a look at that. So we see the same information in the base segment that we were looking at before. Then we have our other user, Anna Sky, that we want to populate with similar but different information and go ahead and make an add call. Now, if you're quick, you can see that under the covers, what's being done are a couple of specific RACF commands, but that also allows for kind of a more hands-on understanding of, oh, this is how these traits are managed. The OMVS UID and home directory and program, they live under that OMVS segment. TSO segment has the same kind, has other kinds of information. So you can see in both the output from the add and the extract that we're putting that together. So then we have just a quick look at trying to connect them to some existing groups. So that's really the connection administration here. We're going to create another connection administration object, and then we're going to connect Luke Sky and Anna Sky to the Jedi group. And again, we can see from PyRACF that we got good return and reason codes. So those ran successfully. And then the last part of this demo is to kind of take a look at this from resource permissions and access. So we're going to create a few different objects for access administration, resource administration, and then setter ops administration. The setter ops administration is just a bit of a personal thing. Working in support, we would often deal with a quick thing that we always have to check, even when people are adamant that they've done it, just because it can so often lead to problems, is if the class is rack listed when you made a change to the profile, did you issue a rack list refresh? Because that's something that if it's not done, your change won't really be done. So the setter ops administration here is just to kind of showcase the programmatic nature of PyRACF's ability to check to see if a class is rack listed and then refresh based on that output if you'd like. But here we are creating the Force resource in our Star Wars class with functionally an R-defined command, but it's our resource admin add. And we want to get the class attributes to see if it's rack listed, and we can see that it is rack listed. Now, you can do, and I have done programmatic things with this, so you can see, oh, if it's rack listed, then I want to issue a refresh rack list command. You could also take a look at coding something that keys off of the message and the response from the alteration to a profile. But in any case, it's something that can be managed entirely programmatically. The get my access is just a matter of the current user's access. So since they created it, they do have alter access right now, but we want to take a look at permitting Luke Sky and Anna Sky update access to the resource, and then going through and refreshing that so that that can be done. So let's take a look at that. Yeah, and again, we can see the positive or zero return and reason codes indicating that we've got this completed. And again, the classic RACF message of the ICH 06011I that indicates that because the class is rack listed, a refresh will be needed for the changes to take effect. So we do that. And I suppose there is one more segment to this demonstration that I had forgotten about. We do want to make changes to our group connections and validate that those go through. So in this example, Anna Sky is no longer a Jedi, he's a Sith now, but it could be as simple as, oh, this user used to work in this job role, he works in this other one now. And we can go check to make sure that our user changed as we expected them to, and we only need the default segment. But right down there, we can see that they're connected to the Sith group now. So that was done. We can also make a quick alteration to just show, oh, we can change names, we can change any other piece of information that we would need to, and again, go back and check. And here we still see that his name is Anakin Skywalker, but if we go issue the display again, Now his name is Darth Vader. So we have our capabilities for being able to do this quickly and handily. And a big part of why personally I'm invested in the idea of Jupyter notebooks with this kind of a script is you could have a kind of self-documenting process where, say, in your organization, users that do particular types of roles have a set of traits, have a set of groups that you want them to belong to, and you can document all of that in kind of an existing run book, and then all you need to do is populate a few key fields and just run through the run book to actually define new users or change users from one role to another in a method that would be instructive, but also functional at the same time. So that's really the biggest aspect. I know that there's still stuff going on in the background, but I'm going to move on from here. So let's go back to kind of our simplification mindset for a moment. Um, we have consistent and well-structured input and output. We have demonstrated that we have easy integration with existing standards and tools, and our abstractions provide us with something that we feel is very straightforward to use. But we also really don't want a case-specific solution. And we thought about this for a while. We had good reasons for choosing Python. We feel very comfortable with our choice of Python. But in a way, it is still kind of a case-specific solution. Um, Looking back at how we interface with RACF, there's TSO commands, there's RACF panels, there's RACF callable services, and now there's PyRACF. And Python is very much a language of today. It's demonstrated very clearly, but there are other languages that are high up there. Someone coming into your organization might not know Python very well. They might not like using Python, when Python in a few years might lose some of the attention that it's had. As we see in this graph, it's kind of plateauing a little bit. So it could be the language of today, but not of tomorrow. So if that becomes the case, PyRACF becomes just another interface in this cluster of interfaces that drives a specific solution that can't be easily implemented. So this led us to look at making it into what we call a universal solution, which is RACFoo. Now, this is another project that's under the Open Mainframe project and the Ambatus org specifically, and it's in the same vein, an interface to RACF administration, again, users and groups and connections between them, resource and dataset profiles and access to them, and RACF options. It covers all the same spaces that PyRACF covers. Um, it also will integrate, it does integrate seamlessly with automation and existing tooling, and it uses, rather than JSON-like dictionary structures in Python, we've moved on to a complete JSON structure setup. Now, the biggest difference is that RACFoo is what we would consider to be a no-frills approach. So PyRACF has a lot of abstractions I talked about. You could user.set password, user.get UID, or get GID, or group.get GID, or something like that. RACFoo is not going to have any of those types of abstractions. It's just going to be the simplest building block possible, and then PyRACF will inherit RACFoo, and it will still be able to offer those abstractions from an instructive Python approach, but RACFoo will have the benefit of being just a small basic building block that anything can build off of. So to look at what that looks like, realistically, RACFoo takes in a single JSON structure and outputs a JSON structure. So that really means that basically any language or programming environment that has either native or good third-party JSON support and has a foreign language interface for C or C++ can work with RACFoo. So just some examples here, and a little bit more of a discussion of how we see this working. Java, Python, Node.js, Golang. We've done a Python and a Node.js, I believe, isn't out on the GitHub yet, but we've done a demo with it and it works well. And then any of those open language exploiters work with our C++, RACFoo, simplification middleware. They pass it a JSON structure, RackFoo parses that, and then invokes one of two different RackF callable services, either SMO, that handled a lot of the that handled all the operations in PyRackF, or the radmin callable service, which offers a little bit more versatility and a little bit more consistency in some of the specific output of features it was working with before. Um, Something that's not on here yet, but is kind of a bit of a breaking news in our space here for RackFoo. We did just merge a commit into main that starts to work with our data lib, the callable service that interfaces with certificates and key rings and things of that nature. So we do already have some functionality that works with that as another callable service, and we could see others come in down the line. Although we have a lot of features to add for our data lib right now, it only does certificate extraction operations. But still, the end result is we want RackFoo to be kind of this simple interface that can connect at, as close to any open language exploiter as we could realistically offer with any RackF callable service that we can offer a functionality to. So for now, it's these administration functions, but it could be more if there's a real need for that in the future. Um, and this is a comparable kind of architecture diagram. Instead of focusing on the class nature and the object-oriented nature of it, here it really speaks more to how the exploiters invoke our program and how that interfaces with the callable services under the covers. So whatever exploiter is reaching out to RackFoo, they pass in a JSON ASCII object, and that comes down to the C++ layer of RackFoo. And then depending on what type of request, it'll route it to one of two different RackF callable services at the time of the current diagram. SMO for add, alter, or delete operations for the users, groups, etc. But extract operations actually run directly to our admin due to the way that our admin structures its output. Um, SMO ends up calling our admin under the covers, which is why this diagram kind of meets back under this our admin callable service, and then our admin will reach out to the SAF layer and invoke RackF as necessary. Um, so I don't have a video demo for RackFoo at this time, but just to give a quick look at what this looks like. Realistically, this is the Python externalized version of RackFoo. So this is still a Python script now invoking RackFoo directly. These print statements are just about debugging. So all that you really have to do to invoke RackFoo, you set up your request JSON to have the operation, admin type, and then traits if that's necessary. Basically, you set up your dictionary with all the information that you need to do what you want to do, and you pass it to RackFoo, and then RackFoo will give you back a result. So in this case, we were doing an extract operation for a user named Squidward, and we come out with this JSON structure version of that profile. And we can see that they have some OMVS segment information, they have some base segment information, and all of that came back to us with this simple call to RackFoo. A slightly amended version of the same script, now with a different request JSON, works for another operation. So here we want to add a user called Squidward, and we want to give them a name, a UID, and a home directory. And so we're going to put all that in our request JSON, and the same call to RackFoo, just passing our new request JSON in. This time it gives us a different structure of output. It shows the commands that were issued under the covers and any responses for RackF from those commands. But what's also meaningful to us is our return codes of 0, so we know that this happened. So broadly, taking this out into what can we learn from this, I want to stress that when looking to simplify, really hone in on what your smallest building block kind of a piece is to put together. And you can always broaden it later. We're planning to do that with RackFoo. We want to bring in more callable services, but we start with that small piece. And we don't want to lose sight of the full mindset of simplification and what we're trying to do. We don't want to wind up with a case-specific solution. Even if we have a fairly broad use case, we want to do that. And then we also, I want to stress a lot that it's important, especially with these kinds of simplification efforts and getting out there, to lean on the existing community. There's a big communal push to kind of do these kinds of simplification efforts, pulling in Python and other kinds of languages to Z environments where they haven't been as present before, is gaining a lot of traction. And there's a lot of good discussion about that in the areas like ours, on our GitHubs and other places out there in the community. So definitely reach out to us or others doing similar kinds of work. ZOAU comes to mind if you're looking to get involved with this kind of simplification. Um, so to speak a little bit about what's coming next, I did spoil this a little bit. RackFu is working on our data lib and certificate support. So that will mean integration into being able to extract certificate information, but also we're hoping to be able to do similar operations like add, alter, and delete, like we can with many of our other existing operations. The next thing for PyRackF is to integrate RackFu as a dependency. Currently, it still uses its own version of backend, and a lot of that is bloat and unnecessary code that it can just lean on RackFu for now. The roadmaps for both of these projects are open and community driven. So if you see something here that interests you, but you want it to have a feature you don't think it has, let us know. And we're very, very quick and responsive. Or if you see something that we did and you don't understand why, ask us about it. We're happy to discuss that or happy to make changes. And we've had a couple of open source contributions on RackFu already. So we're really excited to get involved with that in the community. Please reach out if you want to be involved. My email is at the beginning of the presentation. And then also at the next slide in the presentation, I have links to the repositories. Currently, these go to the documentation, but that basically takes you to the repository for PyRackF and RackFu. I will use this as an opportunity. I have been flying through this and didn't look a lot at the chat. Are there any questions or anything that I could cover really quick while we're here? Or not necessarily quickly. I'm down for longer discussions as well.
Unfortunately, nothing in the chat.
Okay.
I don't know. Anthony, you seem to be having trouble connecting to audio. Was there a question you wanted to ask? Don't know.
All right.
Okay.
Well, oh,
Oh, Brian. Leading question here, but any thoughts about expanding this to RackF for ZVM?
uh, that is an interesting question. It's something that we could look at. I'm not overly familiar with how ZVM's RackF differs from the on-platform version. The biggest requirement on our from our perspective for a RackF or really mainframe environment to work with is just an understanding of the callable services. So if a ZVM environment could interpret calls to the callable services in the same way, then it would already work, is my understanding. Um, but I'm not 100% certain on that, so I'd have to do more digging and get back just to confirm.
Okay. Interesting topic. One thing for me, who would you actually think should be using these? I know you said systems programmers at one point.
RackF administrators would be a big exploiter as well, especially if you're looking to work on automating kind of any of your processes. We've seen some use cases where customers work on automating specific um, processes revolving around defining new users, defining their connections to groups, and managing that. I think the integration with Python made it particularly easy for users to get or specific users to be notified and get approval and then have that approval directly trigger actions where the users were then defined. And that allowed for a big streamlining of existing processes. I know I've seen some areas where when we generate password reset requests and things like that, having that go through a similarly automated but monitored environment would be a way to improve user experience in a lot of these kinds of mainframe environments. So anyone working on the back end of this kind of stuff, working with RecF directly and looking to streamline kind of the processes that they might have to go through for things like that, would be a big potential user.
Anybody else got any questions?
Mhm.
No, doesn't look like there is.
Okay. Well,
No.
I know I have to have the session feedback slide.
You do, yes, please. So please give us your session feedback, 7R for this particular one
Mhm.
today. As I said previously, we do find them useful for future planning. So, and obviously our speakers do like to have some understanding of how the session has gone for them from
Mhm.
your point of view. So thank you very much, Elijah, and see you again soon, hope.
Thank you very much.
Thank you very much, guys.
All right.
Bye.
Bye.